Welcome back to General Chemistry Mini Lecture Series, Lecture 13. Today we are going to go over the second part of a nomenclature, ionic compounds. This is actually a review of what we learned in the past. So we already know group 1A metals, they always just form 1+ cation ions. No exception. Group 2A, 2+. Group 3A for aluminum always forms aluminum 3+. Now the other ones in the family, for these three transition metals, they also always just form 1 cation ion. For silver is always +1, zinc always +2, scandium is always +3. Most of the transition metals, they will form more than 1 cation ions without variable charges. But most of them, they have a 2+ charge. You see, every one actually in this table, they have a 2+ charge. The reason for that is they can easily lose the S2, two of the S2 valence electrons. So that's why they should have 2+ cation ions. Okay. Since this transition metal, they form cation ions with variable charges, then sometimes you need to know how to determine which charge are we talking about. Let's say iron 3 or iron 2. Like in FeO, so then we determine the charge for iron based on the charge of oxide. Oxide most time carries 2 negative, therefore iron has to be 2 positive. So that's how do you get the charge for those cation ions with variable charges. Okay, cation ion name, yes, still the same as the metal's name. I say iron, we still use iron. However, we have some additions here. So we'll write the charge in using a Roman numeral and put that in parentheses. And then we place the parentheses and the Roman numeral after the metal name. That's how we handle cation ions with variable charges. Now, naming binary ionic compounds. Binary means only 2 types of ions. Step number 1, the full name of metal is used first. And for transition metals, so make sure you use a Roman numeral in parentheses. Step number 2, we'll use the stem or the root of the non-metal name, and then using IDE as a suffix, basically we just use the ion's name. So therefore, cation ion first, then the ion. Okay, let's work on one example. Name NaBr. Full name of the first metal, sodium. And then the ion of the second element, that's bromine, and then bromide. So therefore, the full name for NaBr is simply sodium bromide. CO2O3. Okay, write down the full name of the metal. Since this is a transition metal, so we have to indicate the charge. How do we know it carries +3? Because we know oxide is -2. -2 times 3, total -6. Then we need a +6. 6 divided by 2, then for each CO cation has to be 3 plus. That's how you work on it. And then followed by the anion's name, oxygen, then that's oxide. So therefore, cobalt 3 oxide. Let's work on a few more. Name the formula for the following ionic compounds. Ba3N2. Let's look at the ions. So Ba, that's a group 2A element metal, should always form 2 plus cation. So for nitrogen right here, that has to be nitride. So therefore, it's barium nitride, IDE. Calcium, again, that's a group 2A, therefore 2 plus cation. And chlorine is chloride. Each chloride carries -1, therefore it's a calcium chloride. Okay? Just make sure you understand. You see, in ionic compounds, we don't use prefixes. So do you notice that? Prefixes are only used for molecular compound. Kf, potassium, group 1A metal. K plus, fluorine, so group 7A, or one of the halogens. So the anion is a fluoride, potassium fluoride. Iron 2 plus. Again, how did you get the charge of 2? From the charge of the oxide. So therefore, iron 2 oxide. And here, copper. What's the charge for copper? Again, you determine that from the charge of sulfide. Oxygen and sulfur, they are in the same group. So therefore, the S is a 2 plus, 2 minus, I'm sorry. So therefore, copper actually is a 1, copper 1. So therefore, in the name, you have to write copper 1 sulfide. Now let's work on writing formula from the compounds formed between iron 3 and nitrogen. Okay, we are going to follow those 5 steps. Okay, first one, write the symbol for the metal cation. Iron 3, that has to be Fe3 positive. So that's a transition metal. Write the symbol for the non-metal ion and its charge. So the group 5A already have 5 valence electrons, gaining 3 electrons. It will have the octet configuration, so make that more stable, and gaining 3 electrons, of course, 3 negative. Okay, so now you put them together, write the formula, and then the charges become the subscripts. Okay, so iron 3, Fe3, and 3. But you have to remember, have to reduce the subscripts to the smallest whole number ratio. Divide everything by 3, you have Fe N. Okay, and then of course you should check the sum of the charges of cation. That cancel the sum of the anion. Of course, that's a 3 positive, 3 negative. So the overall charge for the compound is 0. So therefore, the name is iron 3 nitride. Iron 3 nitride. Now let's do a few more examples. Calcium and oxygen. Calcium group 2A metal form only 2 plus cation. Oxide. Charges become subscripts. And then reduce the subscripts to the smallest whole number ratio. So therefore the formula should be calcium, it should be CaO, and the name should be calcium oxide. Zinc and sulfur should be Zn2+, although zinc is a transition metal, but it only forms 2+ cation. And the sulfur is S2-, as we just mentioned a while ago. So therefore, again, charge becomes subscripts, reduce, ZnS, zinc sulfide. Aluminum and chlorine, so then you need to remember aluminum has to be Al3+, and chlorine, that's a halogen, always form -1 charge, so therefore we have Al3+ and Cl-. Okay, charges become the subscript of other ion, and this one is already in the smallest whole number ratio, so therefore the name is simply aluminum chloride in this case. Now write the formula for the following ionic compounds. Now we do have names for the ionic compounds. Barium iodide, barium Ba2+, group 2A metal, iodide, that should be I-, and then Ba2. Copper 1 oxide, copper 1 has to be Cu+, oxide of course is 2-. Again, write down the formula, use the charge as the subscript for the other ion. Okay, now let's work on the compounds containing polyatomic ions. So remember we learned those polyatomic ions in previous lecture. Okay, everything when you work on the name or formula for compounds containing polyionic ions, so you follow the same rule as for the binary ionic compounds, okay? Just in addition to that, we will use the name or the formula of the polyatomic ions. That's it. It's just for the anion, you have to use those polyatomic ions. Okay, let's do some practice here. Name the following formulas. We have NH4Cl3, so therefore the first one is ammonium. NH4, the ion name is ammonium, all right? This one should be ammonium and then chloride. Sodium, that's acetate, you see? The polyatomic ion is acetate, so therefore it should be sodium acetate. That's potassium carbonate, potassium carbonate. Okay, now iron, that's iron 2 or iron 3. You determine that using the anion. Anion here is NO2, so which is a nitrite, -1. Then 3 of those, the iron has to be +3. So therefore, iron 3, nitrite. Now from name to formula. Calcium hydroxide. Calcium, group 2A, metal, carry 2 positive charge. That's why the subscript for oxide actually is 2. All right. So oxide, you see, is the name for the polyatomic ion OH. Zinc sulfate. Zinc should be Zn. sulfate should be SO4. So zinc is 2 positive, sulfate is 2 negative. That's why I just ZnSO4. Copper 1, hydrogen sulfide. Copper 1 for copper carries positive 1, and the hydrogen sulfide carries negative 1. That's why you just simply write CuHSO3. The subscripts for copper is 1. The subscripts for the polyatomic ion is also just 1. All right, if it's 1, you never write it. Magnesium phosphate. Magnesium, group 2A metal, always 2 plus. Phosphate is always 3 negative. So therefore, you use the charge as a substrate for other ion. That's why you have Mg3, then PO4, parentheses 2. Writing and naming formulas for ionic compounds with hydrates. What are hydrates? Hydrates are simply waters, okay? So 1 water means 1 H2 unit. Now you see we can have copper 2 sulfate, and then we have 5 waters. Actually, we are going to need prefixes. What we learned from before, from mono 1 to deca 10, in this one, you can have half waters. Okay, then 1/2, we use hemi, Hemi as the prefix. Okay, so therefore, you see, we can name the compound first, just like what we learned, copper 2 sulfate, and then following the prefix first, penta, and then just simply use the name hydrate to indicating waters. Okay, so therefore, this one should be copper sulfate 5 pentahydrate. Okay, and those water can be lost when they receive energy or get heated. Okay, so therefore the hydrates can be lost. So the one with hydrates, we call them hydrate. The one without hydrates, without waters, we call them anhydrates. Okay, before heating, the one contains waters or the hydrates, they look blue. After heating, the waters are removed, so you see they look like more whitish or grayish. That's why actually the anhydrates, those are the materials used in desiccator to keep samples gaining moisture. Because if there's any moisture, these ones would get this moisture first. Yeah, that is one of the applications for compounds with hydrates. Now let's write the formula for these 3 hydrates. Sodium sulfate. So we write down the formula for sodium sulfate, deca, which means 10, then H2O. And between the name and the hydrates, so we just simply use a dot connecting the 2 parts. Beryllium sulfate, beryllium is a group 2A metal, 2 plus, sulfate is 2 negative, therefore it's just simply BeSO4, tetra 4 water molecules. The bath salt, many of you probably use this, Epsom salt. It's actually magnesium sulfate heptahydrate. Magnesium sulfate, and then 7H2O. And now let's do a formula from formula to names. Okay, so that's beryllium, nitrate, tetrahydrate. Number 2 here, nickel, and we know that's transition metal, and we know each chloride carries -1, so therefore nickel has to carry a charge of 2+. So therefore nickel 2, and then an ion's name, chloride, the following, the prefix 6, which is hexahydrate. Nickel 2 chloride hexahydrate. And this one, that should be called calcium sulfate, 1/2 right here. We call that Hemi. So calcium sulfate, hemihydrate. This is the end of lecture 13 quiz. So that's quiz number 1. Select the correct name for the ionic compound K3N. What is K? Potassium. What is N? Nitrogen. Okay, let's look at that. Potassium 3. Potassium is group 1A element. It's not transition. Whenever you see this, that means a transition metal. So therefore, A is not the correct answer. Potassium nitrogen, the first part is correct, but nitrogen, for the second part, you always have to use the ion's name, and nitrogen is an element's name, so B is out. C, potassium nitride. Potassium is correct, nitride is the ion's name. For nitrogen, that's also correct, okay? Then what's wrong with the D? D is also potassium nitride, but B, prefixes used. Prefixes are not needed for ionic compounds. So that's why D is incorrect. You'll work on the remaining ones and also homework problems. And I will see you in lecture 14.